Hey, welcome to Next Gen Manufacturing. We are absolutely surrounded by these incredible advanced composite materials. That's when you take different substances and combine them to get the best of all worlds. They're in the planes we fly, the wind turbines powering our cities, all that stuff. They're super strong, incredibly lightweight, and they are really pushing the limits of what we thought was possible. But here's the thing, right? Here's the paradox. If these materials are so amazing, so advanced, why do we still hear stories about them failing, and sometimes failing catastrophically? Well, that's the big mystery we're going to dig into today, the science of failure. You can think of every material failure like a crime scene. Seriously, it is filled with clues that can tell you exactly what went wrong. And in the world of polymers and composites, the investigators, they usually start with four, let's call them usual suspects that could be responsible for the whole breakdown. So who's in the lineup? Well, first up, you could have a fundamental flaw in the design itself. Or maybe it's a problem with the raw material. Then again, it might be improper use by the person actually using the product. Or, and this is the big one, it could be a critical mistake that happened during manufacturing. So the real question is, which one of these is the main culprit? Well, it turns out that one of these suspects is responsible for more than half of all the premature failures in polymer and composite parts. Get this, 53%. That is a huge number, and it points to one single, overwhelming source of the problem. So let's look at the numbers. Manufacturing takes the cake with that massive 53%. After that, you've got use at 26%, and then design and material flaws are way less common. So why? Why is manufacturing so incredibly critical for composites? Well, see, unlike with metals where you might carve a part from a solid block, with composites, you're actually creating the material and the part at the very same time. This just makes the whole manufacturing process super sensitive and so important to get exactly right. Okay, so with manufacturing identified as our prime suspect, how do the experts actually prove their case? Well, they conduct this meticulous forensic investigation. It's a whole process known as failure analysis, and its job is to uncover the hidden story of exactly how a part broke down. And this is their playbook. It really does start just like a real crime scene investigation. First, you secure the scene. You gather up all the broken pieces, you document everything before it gets moved around. Second, you gather intel. You're talking to operators, you're looking at design specs, manufacturing logs. Then comes the really deep dive, detailed lab analysis. And all of that work, all of it, leads to the final, crucial step, finding the single root cause of the failure. And this is where things get really cool. In the lab, they are hunting for microscopic clues. They're looking for these tiny fractures that can show how a crack started and how it spread. They're searching for hidden voids, little air bubbles that created weak spots. They test for chemical residue, any impurities in the material, or even fibers that were just laid down in the wrong direction. Every single one of these is a piece of evidence that helps them reconstruct the crime. So to really see how this all plays out in the real world, let's open up a case file. This one is fascinating. It involves a brand new, state-of-the-art ship that had this mysterious and really critical failure during its very first sea trial. Okay, so the scene of the crime is the ship's ballast system. This is a whole network of these big composite pipes that move seawater around to keep the ship stable. Now, during that first trial, under pressure, a key part of this pipe system just failed. The break happened right at a glued component, which you can imagine put the entire investigation on high alert. So the part that actually broke, it sounds almost too simple. To keep a big pipe elbow from moving around when the water pressure cranked up, the design just called for two composite rings, they called them stoppers, to be glued onto the pipe. These stoppers would brace against a metal collar and hold the whole thing in place. The strength of the entire system literally depended on the strength of that glue. And when the investigators got the broken pieces back to the lab, wow, the difference between the design and reality was just staggering. The design calculations, they assumed a perfect 100% bond between that stopper and the pipe, but the reality, less than a quarter of the surface was actually bonded the right way. A huge part of the joint either had no glue at all or the bond was totally faulty. So, why was the bond so terrible? Well, the investigation uncovered a critical manufacturing flaw. The stoppers themselves were made from pieces of pipe that didn't even have the same diameter as the main pipe. So to make them fit, the assemblers had to just glob on this thick, uneven layer of adhesive to fill a huge gap. And that sloppy process, it trapped air, it created massive voids and weak spots in the glue, and that fatally compromised the bond. It was pretty much doomed from the start. Now, this ship's story is a perfect example of a manufacturing flaw leading straight to failure. But it also brings up a way bigger question. Why is finding and understanding these flaws not just some technical issue, but an incredibly vital economic one? This chart right here, it explains everything. Let's say you catch that flawed glue joint on the factory floor. The cost to fix it is your baseline. We'll just call it 1x. Okay, but what if you find it right before the ship is delivered? That cost jumps to 60 times that amount. But if you only find out about it after it fails out at sea, in the hands of the customer, like in our case study, the cost just explodes to 150 times the original. This is exactly why catching these things early is everything. And this right here leads us to one of the most powerful ideas in all of modern manufacturing. And it's really at the core of what we talk about on this show, the feedback loop. This is where we make a huge shift, right? We go from just fixing problems to actively learning from them. Instead of just seeing failure as some costly mistake, you start to treat it as a rich source of data, a lesson that gets fed directly back into the system to make it better for the future. And this illustrates the whole idea perfectly. It's no longer a one-way street from design to manufacturing to a potential failure. No, you create a closed loop. The analysis from a failure gives you these crucial insights that let you refine the design, improve the manufacturing process, and hopefully prevent that same mistake from ever happening again. It turns every single mistake into an opportunity to get smarter, which makes the entire system more resilient. So, here's a final thought to leave you with. We often think of great manufacturing as being perfect, error-free. But maybe the real revolution, the heart of next-gen manufacturing, isn't about getting rid of failure completely. Maybe it's about building systems that are just incredibly good at learning from it, turning every breakdown into a breakthrough. Thanks for joining us.